The Open Systems Interconnection Model is a conceptual framework used to describe the functions of a networking system. The OSI model characterizes computing functions into a universal set of rules and requirements in order to support the interoperability between different products and softwares. While Transmission Control Protocol or Internet Protocol is a set of standardized rules that allow computers to communicate on a network such as the Internet.
The third layer, or the network layer, is responsible for receiving frames from the data link layer and delivering them to their intended destinations among based on the addresses contained inside the frame. This layer finds a destination by using logical addresses such as IP or the Internet Protocol. At this layer, routers are a crucial component used to quite literally route information where it needs to go between networks. The second layer is the data link layer, and directly connected nodes are used to perform node to node data transfer, where data is packed into frames. This layer also corrects errors that may occur at the physical layer. The data link layer encompasses two sublayers of its own. The first is the MAC, or the Media Access Control. This provides flow control and multiplexing for device transmissions over a network. The second is the LLC, or the Logical Link Control. This provides flow and error control over the physical medium as well as identifies line protocols. The lowest layer, or the seventh layer, is the physical layer. It is concerned with electrically or optically transmitting raw, unstructured data bits across the network from the physical layer of the sending device to the physical layer of the receiving device. It can include specifications such as voltage, pin layout, cabling, and radio frequencies. At this layer, one might find physical resources such as network hubs, cabling, repeaters, network adapters, or modems.
Layer 7, or the application. This layer is the layer that is closest to the end user. It receives data directly from users and shows the information to them. Layer 7 application protocols are used by web browsers and other interconnected programs such as Skype or Outlook. Layer 6, or the presentation. This layer denotes the portion of the application layer that is not affected by data representation. It refers to the preparation or translation of application format to network format, or network formatting to application format in general. It converts network formatting to application formatting and vice versa. This permits the various layers to communicate with one another. Layer 5, or the session. This layer establishes and ends device connections. It also identifies which packets are associated with specific text and image files, set up coordination and termination between the programs at each end of the session are all functions performed at this layer. Layer 4. This layer manages data transit between the system and the host, as well as error detection and recovery. It is responsible for data transmission coordination between end system and host, how much data to transfer at what speed, where it should travel, and so on.
If OSI has 7 layers, then TCP or IP has 4 layers. Their fourth layer is the application. It is a combination of session, presentation, and application layers. Their third layer is transport, which is the same from the OSI of their fourth layer, transport. The second layer is network, which is the third layer of OSI. And their lowest layer, or the first layer, is the network interface, which is a combination of physical and data link layers.
Here are some important characteristics of the OSI model. A layer should only be created where the definite levels of abstraction are needed. The function of each layer should be selected as per the internationally standardized protocols. The number of layers should be large so that a separate function should be not put in the same layer. At the same time, it should be small enough so that the architecture doesn't become very complicated. And in the OSI model, each layer relies on the next lower layer to perform primitive functions. Every level should be able to provide services to the next higher layer, and changes made in one layer should not need changes in other layers. Here are the major benefits of using the OSI model. It helps you to standardize router, switch, motherboard, and other hardware. It reduces complexity and standardizes interfaces. It facilitates modular engineering. It helps you to ensure interoperable technology. It helps you to accelerate the evolution, and the protocols can be replaced by new protocols when technology changes. Here are some drawbacks of using OSI model. Fitting of protocols is a tedious task. You can only use it as a reference model, and it doesn't define any specific protocol. In the OSI network layer model, some services are duplicated in many layers, such as the transport and data link layers. And layers can work in parallel, as each layer needs to wait to obtain data from the previous layer. Yay!
The essential characteristics of the TCP or IP model are support for a flexible architecture. Adding more systems to a network is easy. In TCP or IP, the network remains intact until the source and destination machines were functioning properly. Here are the advantages of TCP or IP. It helps you to establish or set up a connection between different types of computers. It operates independently of the operating system. It supports many routing protocols. It enables the interworking between the organizations. Here are then the disadvantages of TCP or IP. It is a complicated model to set up and manage. The shallow or overhead of TCP or IP is higher than the IPX or Inter-Network Packet Exchange.